Hello, today we're doing 4.4 notes, angle, side, angle, 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 side, and hypotenuse leg. Alright, so go ahead, take a second and do the exploration. Alright, hopefully you had a chance to pause the video, type in the GeoGebra link, or go and find it online and click it there. Alright, let's go ahead and get started. So, an included side. If the side is between two angles of a triangle, then that side is the included side. So similarly with an included angle, it's between two sides. An included side is between two angles. So the included side is the shared side of the triangle, of the two triangles. Angle side angle theorem. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent by angle side angle. So I can, with angle side angle, I am able to create a congruent statement. So let's start with triangle ABC. So now I have to match that up. So A is just the one curve, so that's D, and then I go across to the two curves, which is E, and then my last one is F. So because of angle side angle, I am able to create the two congruents, or the congruent statement with the two triangles. Alright, so we want to state the theorem or postulate that proves each pair of triangles congruent. So side, 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 sine, angle, side, or angle, side, angle. Something that I find kind of helps is if you label what you have, right? So we have a side, an angle, and a side. So that would make sense that it would be side, angle, side. If you were to say, oh, well, I have all sides, and then you try to include an angle in there, that wouldn't make any sense. Okay, let's take a look at 2. So 2 is a great example. Sometimes we see this and we might want to be like, oh, well, side, angle, side. Well, we don't have any angles. It doesn't tell us about any angles. Yes, all the sides are congruent, so therefore the angles must be, but it doesn't tell us about any of the angles. So I'm going to say that this is congruent by side, side, side. We have side here, side here, side here, and they match up on the other side as well. Alright, I want you guys to go ahead and take a look at 3. I'm going to give you guys a second to try it out, and then I'll give us the answer. Alright, we have angle, side, angle. So that's our answer. I just matched up with, we had an angle, then a side, and then an angle. Alright, go ahead and try number 4. Take a look at this one. Alright, so this one included the reflexive property. So remember the reflexive property, that would mean FH is equal to FH. So I now have a side, an angle, and a side. And same over here, side, angle, and then the same side. So side, angle, side. Alright, let's go ahead and go to the next page. Okay, so now we have angle, angle, side. If two angles and a non-included side, so non-included, that means it's not in between, so it's not this side, it's not in between the two angles, of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent by angle, angle, side. Alright, and then the hypotenuse leg theorem. If the hypotenuse and one leg of the right triangle are congruent to the hypotenuse and the corresponding leg of another right triangle, then the triangles are congruent by HL, so hypotenuse leg. So if we have a right angle, so we have a right angle here, and then we have the hypotenuse, and we have one of the legs. It doesn't matter which leg, we just need one of them. Then we can say that the two triangles are congruent. Okay, so let's do the same thing. We've added a couple new ones to our repertoire of figuring out what these triangles have and how we can say they are congruent. Alright, so for this one, so we have a right angle. So now that we know what hypotenuse leg is, I need to pay attention to when we have a right angle or not. But when we have a right angle, we should also have two other sides in order to use hypotenuse leg, at least. We don't have another side. We only have this one side. So I have another angle, and I have a right angle and side. So that would be angle, angle, side. And it matches up over here as well, right? We have the two angles, the two right angles, and then the two sides. So I can say angle, angle, side. Alright, let's take a look at 6. So we have the two different angles. These ones have two curves and the other ones have one curve. And then I can say that PR is congruent to PR because of the reflexive. So I now have an angle, and then a side, and another angle. Angle, side, angle. Okay, let's take a look at 7. So 7, once again, we have a right angle. So it's a little bit different than just an angle, depending on if we are able to use the hypotenuse leg. We do have two different sides. So we have a side here and a side here. This side is specifically the hypotenuse. And then we have two legs. It doesn't matter which leg as long as we have one of them. So since we have a right angle, the hypotenuse, so I'm going to use hypotenuse for this one. And then I'm going to also go ahead and change this one to a leg. So we have a right angle, the hypotenuse, and the leg. So therefore we can use HL, so hypotenuse leg. Alright, 8, we have an angle, and we have a side, and all those match up on the other triangle as well. We have the one curve, two curves, one line. So angle, angle, side. Okay, let's take a look at number 9. So we have two sides. We don't know anything else. We do need a third part unless we know that there's a right angle. I can say that JG is congruent to JG by the reflexive property. So now I have a side, and a side. So therefore, number 9 is congruent by side, side, side. Okay, let's take a look at 10. So we have a side and an angle. Okay, well, we can once again use the reflexive property. It's not labeled, but this middle line, right, it's congruent in both triangles, so therefore we have another side. So side, angle, side. Alright, let's take a look at example 11. So what additional information is needed to prove triangle ABC and triangle CDE by angle, side, angle? So angle, then a side, and then an angle. We started with the angle. We have the reflexive property in the middle here, and we need another angle. So that would have to be this angle down here, right? Because angle, side, angle, this is an included side. So the side has to be included between the two angles. So I need these two angles here. So let's see if we can match it up. So ADB. So ADB, we have it here. We don't seem to have it anywhere else. Let's go ahead and double check the other one. So ADB, and we should have CDB on the other one. Oh, perfect. There we go. Sometimes it might go the other way, so BDA, but none of them have that either. So that wouldn't have worked. But we could have gone one way or the other. So ADB, or backwards and do BDA. So this one just started with the A, so I knew that I had to look for it in that direction. Alright, I want you guys to go ahead and take a look at example 12. Go ahead and try this one. This one's by angle, angle, side. So the side is not an included angle, or sorry, the side is not included side. So this other angle cannot make that side included. Alright, so let's see, angle E right here. That would have made it an included side, so therefore I know I need A and C. So I have an A here, but it's not matched up with C. C here, it's matched up with A. Perfect. Alright, let's go ahead and try a couple proofs with our new triangle theorems. So remember, our first statement is always going to be what's given to us. So CB is congruent to AB. And angle 1 and angle 2 are right angles. So this is given to us. Let's do CB. I'm going to mark my diagram. Alright, and then the second reason is given to us. Let's go ahead and read that. If two angles are right angles, then they are congruent. Based off that, I know I should be saying that these two angles are congruent. So let's do CBD is congruent to angle ABD. So I'm saying that the two right angles are congruent because it gave us that we have those right angles. Alright, now we can use, let's see, we can go ahead and use the reflexive property for DB. So DB is congruent to DB, oops, not BD, DB, there we go, by the reflexive. So I know we have a lot of stuff that we're working with, but seeing what I had, I knew that DB was the only other thing that I could prove without going around, about, and figuring all that stuff out. So DB by the reflexive, and now I have a side, an angle, and a side. So I can now state that these two triangles are congruent by side and side. Okay, go ahead and take a look at example 14. So once again, we want to start with our given statement. So angle A is congruent to angle C. Angle 1 and angle 2 are right angles. So this one is given to us. So let's go ahead and label A and C. So these two angles right here are congruent. Once again, if two angles are right angles, then they are congruent. So I'm going to say that angle CBD is congruent to angle ABD. Alright, once again, I have two angles. The only other thing I can really prove is that we have this DB is congruent to DB by the reflexive property. And now I have an angle, and a side. So I can do that these two triangles are congruent by angle, side. Alright, so this one, number 15, has a reminder. If two segments are perpendicular, then they form right angles. So the symbol is just a reminder of perpendicular. We have that there. So CD is congruent to AD, and DB is perpendicular to AC. That is given to us. So let's go ahead and mark the CD right here and AD over here. Alright, and then the second reason is given to us again. If segments are perpendicular, then they form right angles. So I can say that angle CBD is congruent to angle ABD again. This time we're just saying, well, they're right angles, so they're congruent with one another. Alright, once again, I'm going to go ahead and use the reflexive property. So DB is congruent to DB. Reflexive. Spelled that wrong, sorry. Reflexive. Okay, and then the last one, so we have a right angle and two sides, so that is going to be our hypotenuse and one of the legs. So I can say that these two triangles are congruent by hypotenuse. Alright, let's go ahead and try a couple more proofs. So let's go ahead and start with our given information. So our first step is to always write down our given information. Angle T is congruent to angle S. Now that we have this written down, let's go ahead and label our triangles. So QP, RP, and then angle T and angle S. So we have a side and an angle. So we need to do another side or another angle. It's going to be hard to prove another side, but I can do another angle. I can do angle TPQ is congruent to angle, I think that's a triangle, sorry. Angle TPQ is congruent to angle SPR by vertical angles. So these two angles are congruent, and now I have an angle, and a side. So I can now prove that, I can prove that these two triangles, TQP and SRP, are congruent by angle, side. Alright, let's go ahead and do 17. So we always want to start with our given information. So AC is congruent to BD, not DB. And then we have angle ABC and angle DCB are right angles. Sorry, ran out of space. And it's given to us. So let's see, AC and BD are congruent, and then we have the two right angles. Well, I can also now do the reflexive property for BC. So BC is congruent to BC, reflexive property. And then since we have this right angle, I notice that I have a hypotenuse as well as a leg. So I can now say that these two triangles are congruent by BCD, hypotenuse, leg. Alright, example 18. KN is parallel to BD, and so this should say LM. Sorry about that. And then we have, let's go ahead and start labeling this. So those two lines down the center, that means they're parallel, and then we show that with these arrows here. So they already drew that for us, which is nice. And then angle KMN is congruent with angle MKL, and this is given. So let's go ahead and, wow, I cannot spell today. So, let me get this out of the way. There we go. So good. Now let's go ahead, KMN, so KMN, this angle down here, and then MKL, this angle there. Beautiful. Alright, we have the second reason. If parallel lines, then alternate interior angles are congruent. So if we kind of imagine this, how we have had it in the past, right? We have parallel lines here, and then we have our transversal. We have one set of interior angles, but those are already named. We have another set here, right? So I can now say that angle, let's say NKM, is congruent to angle LMK. Okay. Alright, and then we can use the reflexive property. So for KM is congruent to KM, reflexive. Okay, go ahead and get rid of a couple of these lines. There we go. And so now I have an angle, an included side, and another angle. So I know that I can prove these two triangles by angle side angle. Triangle KNM is congruent to triangle NM. Alright, those are all our proofs for today. Let's finish up with what additional information do we need to prove that ABC is congruent to CDE by angle, side. So two angles and a side. We have our two angles, so we need to prove either this side or this side. I cannot prove that included angle, so I can't, or that included side, sorry. I can't include this because that would be angle, side, angle. That is different than angle, side. So let's see what matches up. So we have AC for the first one, so AC, which means we'd have to have CE. That does not match up. Alright, BC is next, so if I have BC here, I should match up with DE. Oh, that one does work. Let's just double check the other ones just to be sure. BA, oh, that's already a no-go because it's the included side. And then CB, so let's see, CB is here, so we would need ED, and that doesn't work out either, so it definitely is. Alright, and there is the end of 4.4. If you have any questions, make sure to ask your teacher. Have a wonderful day.